Today we will solve assignment problem that was assigned to you. So we will entertain only few problems in which you all are having problem. So the first problem that we are going to entertain is a non-uniform linear charge density rho L lies along z axis. The potential at this point in free space. So two data is given to us. The charge distribution, it varies, it is along z axis. So according to the problem, this is the charge distribution, line charge. Okay, it is in the z direction, z axis, from it is infinite and minus infinite. Okay, along z axis the charge distribution is there. Now we have to find the potential at a point 100. So if we have 100, it means this point lie at x axis as y and z coordinate is 0. So this is the point P, that is 100. We have to find the potential at this. This is x axis and this is y axis, this z axis. So from this charge distribution we have to find the potential at this point. Okay, so for that purpose, first try to find take an element that is dz, try to find the charge that is available in dz, and from that charge find the potential at this, because for any charge we know the potential at any point away from that. So if we know the charge and we find the potential from that charge at this point, then we will integrate this for full distribution, that will give the total potential from this charge at this point. So this is the basic concept. So let us try to start. That is, first we have considered an element dz, and dz, there will be charge in that will be dq, and dq will be rho L, that is the charge distribution density, times dz. This will be charge for this element. And if we wish to find the dv from that charge, then that is nothing, 1 by 4 pi epsilon naught in free space q, that is available here, q by the point of interest, the radial distance from there to here, this. So this is the simple formula that we know. Now just we have to put the dq and r value from here. It will give us the potential. So dq is just integration of rho L with z. So this is 6 divided by z square plus 1 into dz, 1 by 4 pi epsilon naught. R will be there. R is 1 square. It is at distance z. So what we can say, 1 square plus z square will be, square root of this will be r. So if we write r in terms of z, then we can say 1 by 4 pi epsilon naught 6 by z square plus 1 times 1 by 1 plus z square half with dz, it will be dv. Okay, and if we will integrate this, we will simplify this, then it will be 6 by 4 pi epsilon naught 1 by z square plus 1 power 3 by 2 dz. It will give you dv. And for full distribution of the charge, integrate this. the limit of the integration should be from minus infinity to infinity. Okay, when we are considering with respect to z. Z varies from minus infinite to infinite. Now just integrate this, and for integration we have 6 by 4 pi epsilon naught. I think to integrate this, consider z is equal to tan theta. It will simplify the problem. So if you will consider z is equal to tan theta, theta is this is the theta. You can say if we consider z is equal to tan theta, in that case we can say z is equal to the dz will be equal to the dz by d theta will be sec square theta, just the differentiation of this with respect to theta and d theta. Okay, so when z will vary, z will be infinite, then theta will be how much? 90 degree. When it will be infinite, it will be 90 degree. When it will be minus infinite, it will be minus 90 degree. So if we will take from here we can say if z is equal to infinite, then theta will be 90. If it will be minus infinite, then theta will be minus 90. So if we wish to find, then we can put the limit from minus 90 to plus 90. From here, z is equal to 90, z is equal to infinite, theta will be 90. Z is equal to minus infinite, theta will be just tan inverse minus 90. And here 1 by z square will be tan square theta plus 1 times 3 by 2, and dz will be sec square theta d theta. Okay, now simplify this. 6 by 4 pi epsilon naught, tan square plus 1, it will give us sin square by cos square here, cos square plus sin square 1, sec square, sec to the power 3, sec will go up, it will be cos theta d theta, integration from minus pi by 2 to pi by 2. Now integrate this 6 by 4 pi epsilon naught, it will give us cos theta integration, it will give us sin theta, and sin theta if we will integrate from minus pi by 2 to pi by 2, it will give us 2, sin 90 minus sin 90. So it will give us 2 6 by 4 pi epsilon naught into 2. So we can say this is 9 into 10 to power 9. Either we can, I don't know the answer is given in which form. So if we will simplify this, it will give us the final result. So we can say 12 into 9 into 10 to power 9 into 10 to power minus 9. 9 into 10 to power 9. 1 by 4 pi epsilon naught is nothing, just 9 into 10 to power 9. So this is in nano is there. So this nano will die out, and if 12 into 9, 108. This will be the final answer of the potential at this point due to this line charge. Okay, hope there is option 108, that will be okay. Okay, now let us come to next question, that is 2-point charge Q1 and Q2 are placed at coordinate this and this. Total flux passing through a plane z is equal to 0 will be. Okay, so here we will consider a plane at z is equal to 20. So we can consider a x y and z. Z is equal to 20. Consider a plane at z is equal to 20. Okay, and one charge is at 110. It will be in xy plane because z coordinate is 0. So x is equal to 1, y is equal to 1. It will be here 1 1 0. Next point is minus 1 0. So that is here, minus x will be here, minus y will be here, just mirror image of this. Next point will be here, minus 1 and 0. There are 2 points. Okay, now the flux passing through this. So if we make a Gaussian surface for that, then we can consider another infinite plane at z is equal to minus 20. Okay, and these two planes enclose full charge. So the total charge enclosed by these two is total charge enclosed is at this point the charge is 10 microcoulomb, at this point the charge is 20 microcoulomb. So total charge is 10 plus 20 microcoulomb. Okay, so the flux will be the total charge enclosed by that. We know this simply. So it is 30 microcoulomb will be total charge enclosed. However, just we have to find the flux passing through this surface. So that will be simply half of that. So the total flux right here, the total flux from z is equal to only one plane will be 10 plus 20 divided by 2. That will be 15 microcoulomb. If it is in the answer, then that is the correct one. The total flux from this plane, that is z is equal to 20. Now the next problem, that is question number 11. Lossy capacitor Cx rated for operation at 5 kV is represented by an equivalent circuit with an ideal capacitor Cp. Then the power loss and time delta of the lossy capacitor operating at the rated voltage respectively are. So this is the lossy capacitor, and if it is here, it is represented here, then Cp is the ideal capacitor and Rp is the resistance of that. Okay, so this lossy capacitor can be represented by Cp in parallel with Rp, and after this representation we have Cp and Rp and the operating voltage. So from here, since capacitor is ideal, so power loss will not be there in this part, because ideal capacitor cannot dissipate power. It can store energy, and then charging and discharging takes place. It will not lose the power. So as the capacitor is ideal, it will not cause any power loss. The loss will occur here only. So from there, as the voltage is across this is 5 kilovolt, then we can say loss, that is power, is V square by R. We know this, and R is Rp. Now V is given here 5k square divided by Rp is given 1.25 mega ohm. So from here it will be 25 into 10 to power 6 divided by 1.25 into 10 to power 6. These two will be cancelled out. 25 by 1.25, it will give us 5 by 4, 20 watt. So total power loss will be 20 watt. Okay. So the loss will take place in the RP part. There will be no loss in the capacitor, ideal capacitor. And the tan delta, we have the simple formula for that. Tan delta is nothing but XC divided by XR. XR means just R. So XC by R is tan delta, and XC we can XC is, if we write XC, then we can have 1 by 2 pi f c. This is called FC. So we have frequency of operation. C is nothing, just Cp. So from here we will put 2 pi f Cp, and R is already given to us. So every term is known to us just by putting them. 2 pi f Cp, that is given here, 0.102 microfarad, and Rp is given here 1.25 mega ohm. Mega and micro can be cancelled from here, and 550 and 2 can be 10.2, and if we will simplify, then we will get value that, let me check what will be value of this. It will be yes, it is 0.025. so this is tan delta. So this is the power loss in the lossy capacitor. This is the tan delta. Okay. Now next question is coaxial cylindrical capacitor shown as dielectric with relative permittivity 2. Okay, this is the capacitor. The relative permittivity of this is 2. When 1/4 portion of it is replaced with another dielectric, so 1/4 means this portion is replaced by epsilon R2, another dielectric material. Then we have to find the value of this dielectric material permittivity. Simple formula in the case of coaxial cylindrical capacitor, we have derived it. The capacitance is 2 pi epsilon, the length we can say h divided by the outer radius divided by inner radius. So we can say B by A. We have derived it. So in this case, the capacitor is, for example, 2 pi, let us say it is C1 and it is C2. So C1 is 2 pi epsilon is epsilon R1 for this case, that is 2, leave it as H divided by natural log B by A, and B is natural log R by small r. This is C1, and in this case C2 will be the capacitance of this portion and parallel with the capacitance of this portion, because the potential both will have the same potential. So both will be in the parallel, and if they are in the parallel, then this is this portion. For this portion, C will be, and in parallel we can say it is C3, and for this portion it is C4, and C3 in parallel with C4, then it will be simply C3 plus C4, and C2 will be C3 plus C4, and C3 will be 2 pi epsilon. We don't know this portion. Epsilon is 2, and H will be 3 by 4 of that divided by 2 pi divided by natural log R by R. It will remain same, there will be no change at all, and plus C4 will be, for this portion the H will change and epsilon will change. So 2 pi epsilon, we don't know, that is epsilon R2, and H will be H into 1 by 4 portion divided by natural log R by R, the outer radius divided by inner radius, according to the formula. This is C2, and according to the statement, this capacitance is just double of this. So we can say C2 will be equal to the 2C1. Okay, the capacitance is just doubled. So if we will put it here, then C2 means 2 pi 2 H 3 by 4 divided by natural log R by R, that is C2 is the sum of these two, so this part, plus 2 pi epsilon R2, that is required to know at this time, H by 4 divided by natural log R by R. By 4 is the division of the part, division of this full cylindrical circumference, cylindrical body into 3:1. This is C2, and C1 will be 2 pi 2 into H divided by natural log R by R. Just I have placed C1 here and C2 here, and remaining thing is same according to this. So here it will be cancelled out, H will be cancelled out, 2 will be cancelled out, pi will be cancelled out. What will be left here? 6 by 4 plus epsilon R2 by 4 is equal to 4. Okay, to make it simplify, this we can write 16 by 4, 4 will be cancelled out, epsilon R2, 16 minus 6, it will give us 10. If it is there in the option, then the permittivity of this material should be 10, so that the capacitance of this combination should be double of this. Now next problem is problem number 15, that is, if the function is given here, we have to evaluate the line integral evaluated over contour C, that is formed by these segments. So according to the problem, that is the gradient of f dot dr for the full contour path we have to find. So for this closed path we will try to find this. For this we have to find the gradient of f first, then we will try to find the integration for all these segments. So just let us find the gradient of f. We know that this is del over del x fx in the direction of x, del over del y fy in the direction of y, and del over del z in the direction of k. Okay, so from here we can say this is f is 2x cube 3x square 3y square plus 4z. From here we can get 6x square plus 6y from here, and from here we can say 4k. So we have del f. Now this can be written as del f from 1, 2, 3, 4. So we can see it can be written as from 1 to 2, from 2 to 3, from 3 to 4. And if we put the value 6x square I plus 6yj plus 4k dot dxi dyj plus dzk, then from 1 to 2 minus 3 2 to 2 minus 3 2. Y coordinate and z coordinate remains as it is, only variation is in x. So what we can get, 6x square, the dot product of this will be 1 and remaining will be 0, 0, 1, 0, 0, 0, 1. So we can get 6x square dx plus 6y dy plus dz4, but the variation in x is minus 3 to 2, and there is no change in y and there is no change in z. So it will be 0, only this term will be there. So we can say 6x cube by 3, so it will be 2x cube. Okay, that is from minus 3 to 2. Okay, now for next portion, x remains same, only y changes. So we can say for this we can say from 1 here, from 1 to 2, and from 2 to 3 we can say only y changes. So 6y dy, and this term will be 0 from 2 to 3. So only y is changing, so that will be from minus 3 to 6, and it will give us, okay, we can keep it without solving this at this stage. Okay, and from 3 to 4 only z is changing. So from 3 to 4 only z is changing. So 4 dz from, that is x remains constant, y remains constant, 2 and minus 1. Okay, so sum of 1 to 2, 2 to 3 and 3 to 4 will give us the total integration through the contour. So from here, if we integrate, then it will be x2 minus 3, it will give us 2 times x power 3. It is 8 minus 27, so it will be plus 27. It will be 70, and here it will be 6y square by 2 from minus 3 to 6. So it will be 3. If we will solve, then we can get 3 into 36 minus 9 times 3. It will be how much? 9 27 times 3, 81. If we will solve this, it will be 4z from 2 to minus 1, and it will be 4 into minus 1 minus 2, so it will be minus 12. So from 1 to 2, the value is 70. For full contour, it is 70 plus 81 from 2 to 3 and minus 12 from 3 to 4. Including all, it will be 151 minus 12, that will be 139. Yes, so it will be 139. It is the final answer if we will integrate this for the full closed path from here to here. So the key point is, when we will divide it into different segments, then from in first segments only x is changing from here to here, from here to here, y is changing from here to here, only z coordinate is changing. So remaining coordinate will remain unchanged, and due to that the limit will give us 0. When we will put the integration limit, it will give us 0. Now next problem is, that is the 17th problem. A positive charge of 1 nanocoulomb is placed at 0.2 coordinate where all dimensions are in meter. Consider the xy plane to be conducting ground plane. This is the important term for us. The z component of the field E at this is how much? As it is said, xy plane is assumed to be conducting, so it is considered as z xy plane means z is equal to 0. So we can say z is equal to 0 is our xy plane, and it is assumed as conducting plane. So this is normal, this is conducting plane, and charge of 1 nanocoulomb lies at 0, 0 and 0.2 coordinate. This is point P, whose coordinate is this, and the charge is 1 nanocoulomb at this point. And the z component of the field at the point 0, 0, 0.1. We have to find the field at this point. In this problem, one important term is included, that is, this is conducting plane, and if the plane is conducting, then a charge of same value will be induced with opposite polarity at the same distance from the conducting surface in opposite direction. Okay, so it will be minus 2 and the charge will be 1 nanocoulomb. This is the law, and from that we have that another charge, it can be assumed that another charge of minus 1 nanocoulomb is assumed at this point. So now we have to find the electric field at this point due to this charge and this charge. From both of them we have to find the electric field at this point, and the equivalent of these two will give us the net electric field at this. So from here to here the field will be, it is positive, so field will be in this direction, okay, that is in negative z direction, and due to this the field at this point will be, as it is negative, again it will be in negative direction, okay, so towards the negative charge, so it will be also in this direction. So total field will be sum of the field from this charge at this point and the field from this charge at this point will give us the total field at this point due to these two charges. Actually they are giving that there is only one charge, but they are giving that this is the conducting surface plane, so due to that another charge is assumed here. Okay, so from here we can say E, if it is 1 it is assumed as 2, then from we can say E12 will be equal to Q R12 divided by 4 pi epsilon naught R12 cube. Actually the formula is KQ by R square in the direction of AR. So AR can be written as R divided by magnitude of R. So from here we have written AR can be written as this. So we have written R12 divided by R12 magnitude. That's why this term comes at the top. And R2, from here we can say Q is 1 nanocoulomb 10 to minus 9, and R12 is how much from here to here, or we can say final minus initial. R12 means R2 minus R1, that is 0.1 minus 0.2, that will be 0.1 with minus sign, and it will be in the minus z direction. So we can say in the minus z direction, okay. R12 itself include in this direction, so it will be minus 0.1 in the direction of AZ. This length in the direction of AZ. Either we can say this sign will be due to, this is the final sign for R12, divided by 4 pi epsilon naught. R12 can be written as 0.1 to the power 3. Okay. Similarly, E, we can say from this to this point 3 2 we can say will be Q R32 divided by 4 pi epsilon naught R32 cube, as we have done here. So Q is nothing, just minus 1 into 10 to power 9 minus 9 divided by 4 pi epsilon naught, and R32 is it is 0.2 and 0.1, so it will be 0.3. to the power 3, and this will be final minus initial should be 0.3, and it will be in the direction of AZ. So we can say AZ times 0.3. Actually it should be 0.3 in the direction of AZ. Okay, leave it. So the total electric field will be, both are in the same direction, so total electric field will be E12 plus E